Hello, my name is César.
Hi there, I'm Giancarlo.
Hello everyone, I'm Melanie and we're team number 3.
Today, we will be showing you how to perform long divisions with polynomials. We hope you enjoy it, and let's get started.
Divisions with polynomials are, in a sense, the same as a traditional arithmetic division. No matter how much we try to identify another form of interpreting them, the simplest procedures will derive from performing an arithmetic division with algebraic expressions.
Let's make an example for you to better understand what we're proposing here. Let's perform the following problem. 2 times a number to the 4th power, which we will represent as an x plus 8 times a number to the 3rd power, plus 2 times a number, plus 8, all divided by a number plus 4. Sounds confusing, doesn't it?
Just like an arithmetic division, we will consider as many monomials inside a dividend as possible, according to the size of our divisor. In this case, 2x to the 4th power plus 8x to the 3rd power are the monomials we can take to start, since our divisor is a binomial as well, x plus 4. Then, we proceed to find a monomial which equals the first one in the dividend when multiplied by x, the first monomial in the divisor. In this particular example, 2x to the 3rd power times x equals 2x to the 4th power, the first monomial of the dividend, as we have agreed. The difference between them is 0, yielding no remainder at all. We can continue multiplying our monomial by the divisor, now considering 4, which produces a result of 8x to the 3rd power. The difference between it and the second monomial of the dividend is 0 as well, situation that leaves no remainder at the bottom.
Or does it? No! God, please, no!
Why is there a 0 squared x between the 3rd power and the linear variable? It has to do with maintaining a determined form for the polynomials in the division. There is a form of stating polynomials known as standard form, where each monomial is organized in a descending exponent degree from their respective variable. If there is a sudden jump from the 3rd power to the first one, there must be something in between to fulfill the 2nd power. 0 is the most appropriate answer since it affects nothing in the whole operation. Next, we continue descending monomials until we reach our next limit, 2x. By itself, 2x is very small to be divided by x plus 4, so another monomial is taken down, this time 8, the independent factor.
Following the first procedure used on this division, we multiply every remaining monomial in the division by our next response. 2 times x equals 2x and 2 times 4 equals 8. The difference between 2x plus 8 and itself is null, producing no remainder in any form. The exercise is virtually completed, we just need to state the answer properly. As you may observe, the zeros will be disposed as they contain no valuable information for the response, but we include them here anyways because we love you and we want you to fully understand this topic. At the end, the final result for the initial problem we stated is 2x to the 3rd power plus 2, this time with no remainder to state in the form of remainder over the dividend.
There are certain divisions with a divisor in the form of x plus minus k, where x is our variable and k our constant. Because of this special property, we may solve this operation applying the Ruffini's division, first postulated by Paolo Ruffini between 1810 and 1813. This process is very simple, and it will help us to get our answer sometimes even faster than applying a quotidian long division. We will take the following problem as example. A number to the 3rd power plus 3 times a number squared plus 3 times a number plus 1, divided by the sum of a number and 1.
How can we apply Ruffini on this example? We first need to take the divisor, place an equal sign at the right and write a 0. This will create a linear equation for us to solve. The result is equal to -1, the number we will write at the leftmost part of the structure. Next, place the coefficients of the monomials in decreasing degree order. In this example, the numbers will be 1, 3, 3, and 1. To start performing the division, place the first number below the line and multiply it times -1. In this case, 1 times -1 equals -1. We will place this number below the next coefficient, which is 3, and add them to make a 2.
We will repeat this process several times until we run out of coefficients at the top of the division. Once we're finished with the division, we must express the results in standard form. Starting from the rightmost number, which will be the remainder of the division, the degree of the monomials will increase by 1, starting from the independent term with a degree. Consequently, we will have as a final answer x squared plus 2x plus 1, with a remainder of 0 over x plus 1.
As you may have inferred, both processes lead to the same answer, one of my personal favorite features of mathematics. Despite one process seemingly harder than the other one, both are ideal for certain divisions, which should be determined by a person who is attempting to solve the problem. This has been everything for this video. We hope you enjoyed it, and thank you for your time and attention.